The lighting setup in a 3D scene is probably the most important phase, since it's through lighting that we can give objects depth and realism. So let's see how to proceed. Before setting up the lights, let's assign a slightly reflective material to the backdrop. This precaution will allow us to better evaluate contact reflections during the lighting setup. Select the backdrop and, in the Properties window, open the Materials tab. Click on New and open the Preview panel to see a preview of the material. In the Surface panel, change the roughness value to 0.3. The preview immediately shows us the result of this operation. Now let's move on to setting up the lights. A simple approach to start lighting our piece of furniture is to use an ambient light. In the Render panel, change the Render Engine option to Cycles. Set Device to GPU. This way, we tell Blender to use the graphics card, which is much faster for all rendering phases. In the Viewport panel, check the box for the noise. Go to the Output tab and enable the Render Region box. This setting allows us to limit rendering exclusively to the area visible through the camera. By ignoring elements outside the field of view, we can significantly reduce the software's workload, optimizing resource usage. In the Properties window, open the World tab. Increase the value of the color parameter to 0.8. In the viewport, press the Z key and from the pie menu that appears, choose the rendered option to perform a test render of the scene. As we can see, the sideboard is now illuminated. However, since the ambient light comes from all directions, the object does not have any defined shape. This makes the image quite confusing, with poorly defined shadows and reflections, and above all, lacking depth. Therefore, let's turn off the ambient light by setting its color to black and start setting up the photographic set. For convenience, let's split the viewport into two vertical windows. In one, we keep the camera view so we can always keep an eye on the results of our changes. In the other, we switch back to the perspective view. In the outliner, right-click and create a new collection which we'll call Lighting, where we will place our lights. The goal is to create a set of lights following a specific hierarchy, starting with a fill light which, positioned behind the sideboard, is meant to make the backdrop very bright. In the Perspective window, press Shift+A, click on Light and then select Area. Press the 3 key on the numeric keypad to switch to the right side view. Also set the display mode to wireframe. This will allow us, with the backdrop's profile clearly visible, to better position the light source. With the area light selected, set the Y and Z values of the location parameter to 200 centimeters. Press R, hold down the Control key and rotate the light by -45 degrees. You can monitor the progress in the top left corner of the window. Alternatively, you can set a temporary value and then enter the correct measurement in the Rotate panel, located in the bottom left corner of the 3D view. At this point, the light should be positioned behind the sideboard and aimed so that its beam points toward the curve of the halo. In the Render window, you can start to see the effect of this light, even though the current lighting is not adequate. After running some tests, I have identified the optimal settings for the size and power of the light. Let's open the Area Light tab and set the shape parameter to rectangle. Increase the X value to 500, Y to 150, and also raise the power to 200. We can see that now the backdrop is white, the horizon is not visible, and the light bounces off its curve. It is also able to produce contact shadows and reflections. In the outliner, let's rename this light to Fill Light. Now we also need to light the sideboard. Let's continue in our lighting hierarchy by creating a key light. In the outliner, select the lighting collection to activate it. Go back to the 3D view and create a new area light. In the outliner, rename the new light to Key Light. Now let's perform a snapping operation that will be very useful for positioning the light. With the light selected, go to the Properties window and open the Constraints tab. Open the Add Object Constraint panel and select the Track to option. Select the eyedropper and click on the empty object of the sideboard. If we now move the light along the Y and Z axis, positioning it behind the sideboard, we'll notice that it continues to point toward the sideboard. This happens because the light is directly linked to it, ensuring that the focus remains constant despite the movement. Let's adjust the Y and Z values by setting Y to 100 and Z to 200 centimeters. Let's open the primary lights panel and also increase its intensity to 50. The sideboard is now much more illuminated. However, what we've done has significantly reduced the reflections and contact shadows that we achieved with the fill light. In fact, if we turn off the primary light, we can see that the reflections and contact shadows become clearly visible again. To solve this problem, we'll use a very useful option, though not entirely realistic, introduced in the latest versions of Blender, and for this purpose, it works perfectly. What we basically need to do is exclude the backdrop from this light. Let's select the primary light. In the Properties window, open the Object tab. Click on the Shading panel and then on Light Linking. Click on New. At this point, simply drag and drop the limbo collection, or just the geometry itself, directly into the field that has opened under the Light Linking section. If we now uncheck the box for the limbo geometry, we can see in the render window that the reflections and contact shadows have reappeared while the upper part of the sideboard remains illuminated. However, what we just did has removed all the light that the limbo was reflecting onto the front of the sideboard, which now appears very dark. A further step will therefore be to create a new hierarchy of lights, the secondary lights on the left and right. In the Perspective window, with the lighting collection selected, let's add a new area light and rename it to Left Secondary Light. For this light as well, we apply a constraint to the empty object of the sideboard to attach it and move it more freely. Once this step is done, move the light to the left of the sideboard using the various views to help position it more accurately. Place the light according to these guidelines obtained from the various tests carried out previously. Set the X field to -130 cm, the Y field to -210 cm, and the Z field to 90 cm. Let's also open the Lights panel and increase its power, setting the value to 15. Now, using the Shift-D command, let's make a copy of the light, and immediately confirm with the Enter key. Rename the area light to Right Secondary Light, and move it to the opposite side to also illuminate the right side of the sideboard. Here as well, we position the light according to these guidelines obtained from the various tests carried out earlier. Set the X field to 255 cm, the Y field to -85 cm, leave the Z field at 90 cm, and keep the power unchanged as well. At this point, we can see that compared to the initial lighting achieved using only the ambient light, now the piece of furniture is well lit, has shape, and we have also maintained the shadows and reflections. Even though the result we've achieved is definitely good, we're not done yet. In some cases, it may be necessary to have greater control over the contact shadows and reflections. Therefore, we need to make this factor manageable. We could solve this by reducing the reflection parameter of the limbo material, but this operation would lead to a noticeable change in the entire scene. Alternatively, we can turn the ambient light back on, but as we can see, in addition to reducing reflections and shadows, this results in the scene being overexposed. So once again, we solve the problem with a photographic approach, and we do this by adding a fairly large light that illuminates the entire scene from above. This is a butterfly light, which is very often used in photography studios specifically to photograph objects, even those of large dimensions. So we select the lighting collection, and using the Shift key combination, we access the menu from which we choose Light, then Area. We rename the new light to Butterfly Light. As we said, this light needs to illuminate the entire scene, so we move it upward along the Z-axis, specifically to a height of 250 centimeters. Let's also open the corresponding tab in the Properties window and change the size value to 300. Now, by adjusting the light's power, we can determine the intensity of the reflections and contact shadows. In my opinion, a power of 20 should provide a good balance between shadows and reflections. Before finishing this lesson, let's further refine the quality of the final image with a few small adjustments that can enhance its visual impact. In the Properties window, let's open the Render tab and locate the Color Management panel. We open it and set View Transform to AGX, look to very high contrast, and if necessary, slightly increase or decrease the exposure parameter. The current lighting setup is already quite effective, although some adjustments may be necessary once the materials are applied to the mesh, a topic we will explore in more detail in the next lesson. Before wrapping up, as always, let's save this file as a new version.